Good day, folks. Nice to see you all back for the OpenLDAP discussion. In the last couple of sections, if you have managed to take time to watch all of it, we talked about the installation and configuration of OpenLDAP on a Solaris 11 machine. And also in the last section, an apparently lengthy one, we talked about the various types of operations we perform in OpenLDAP, like LDAP search, LDAP add, and LDAP modify command. We also had a look at the LDIF file, a format that we use to import data into the directory server. Just in case if you had trouble bringing up an LDAP server on the operating platform of your choice, I would request you to kindly ping me on ask@fedg.com so that I could offer whatever assistance possible to help you get a setup up and running on your platform, on your operating platform. By and large, the discussions that we had around OpenLDAP on Solaris 11 operating platform should work just the same way on other platforms, except for the way we stop and start the LDAP server. In this section, a very important one, we would be dealing with how you could configure the different audit mechanisms in an OpenLDAP. Maybe you're interested to know or keep track of the activities that happen on the OpenLDAP. Maybe the read operations or the write operations or the bind operations or the unbind operations. You may also want to keep track of the exact modifications that happen on your LDAP server. What are the different types of modification operations happening on my system, and who is doing that? Who is in fact modifying the data in my system? Some kind of audit mechanism has to be in place, especially when we talk of identity repositories like OpenLDAP. It's anyone's concern. But before we talk of the different logging and auditing mechanisms that are available on the OpenLDAP, it is very important to talk of another concept in the OpenLDAP. But before I do that, let me just give you a quick review. I hope you remember that the OpenLDAP service is actually a daemon by the name slapd, which is what you see there on the whiteboard. slapd is standalone LDAP daemon. Now, the original design of this daemon had two endpoints. So maybe this is the first endpoint that I would consider, and this is the second endpoint that I would consider. Of course, this is a very conceptual diagram that I'm making here. This side is what we refer to as a front end, and this side is what we refer to as the back end. I mean, no prizes for guessing that. So we could divide the architecture of the slapd having consisting of two separate endpoints. One is the front end and the other is the back end. In fact, front end is what deals with the activities like network access and protocol translation. So basically the client connectivity and all of that is managed by the front end of the slapd daemon. Whereas backend is your actual data store. Who is storing the data? What is storing the data? The exact operations or exact technique using which the data is stored in the LDAP server, that's dealt by the backend. There are many options we have. In fact, in our discussions in the past, we kept talking about BDB, which is the Berkeley DB option that we have. But apart from Berkeley DB, there are other options also. If one needs to decide, if one needs to choose a different data store for your OpenLDAP, that is also possible. I mean, you don't have to stick to something like a Berkeley DB as the backend database for your OpenLDAP. You have HDB, you have MDB, you also have NDB, which is in fact a MySQL data store engine. It is used in the MySQL cluster. So I'm just saying that there are multiple options. Even LDIF file also, you could use the LDIF as the backend store for OpenLDAP. So if you look at this very dirty conceptual diagram on my whiteboard here, the slapd, which is a standalone LDAP daemon, has two modules, one the front end and the other one is the back end. Front end is what deals with the network access and the protocol translations, whereas the back end is what deals with the actual storage of the data. And there also you have many options. You decide to use BDB, fine, or HDB or MDB or NDB or even LDIF file for that matter. Now, there is also something known as, if you look at the front end and the back end, maybe there are situations where you might want to do something in the middle, right in the middle. Of course, there is a client trying to access the content of the LDAP server, and the LDAP server would fetch those details from the backend database. But there are things that you might want to do in the middle. For example, as an maybe a client is connecting to the LDAP server, and the client is performing a search operation on the backend database. So the front end is actually going to deal with the network access, then it translates the protocol, and then finally it might have to also let's say the client changes the password, or maybe it might also have to log that information somewhere. So this is an activity that takes right in the middle. Some client came and queried something on the LDAP server. Now I have to record that operation. Or maybe another example could be a client is trying to reset his or her password on the database, and when he or she does that, I want some software component to verify the sanity of the password. Is he or she using the password that is acceptable as a password, or is it just another easy word or a guessable word? That so some kind of password policy I can actually put right in the middle of the front end and the back end. So I hope you get the idea there. The front end deals with the network access as well as the protocol translations, whereas the back end is where the data is stored. But right in the middle of the front end and the back end, there are situations when you might want to do something like logging, or something like verifying the password, the changes are adhering to the standard of your site and all that. Now this plugin, what you plug in right in the middle of this, right in the middle of the front end and the back end, is what we refer to in OpenLDAP as overlay. Overlay is a software component that is sandwiched right in the middle of the front end and the back end, and this is a very important concept in the OpenLDAP there. So here is a recap of what I told you so far. The slapd daemon, standalone LDAP server daemon, has a front-end functionality and a back-end functionality. That has been the design from the very beginning. The front-end functionality is about the network access and the protocol translations, whereas the back-end activity is where the data is stored. Now what you want is something right in the middle, sandwiched between the front end and the back end, which does something for you, and that something could be logging the information. Maybe it is an access log, who is binding, who is unbinding from the directory server. Maybe it is an audit log, who is modifying the information in the LDAP server. So you're basically plugging some software right in the middle of the front end and the back end, and that's what we refer to as overlay in OpenLDAP. The biggest advantage of this is that the design or the implementation of the back end and the front end has actually nothing to do with this. You can plug in the overlay, and as long as the overlay is supported, you can actually keep plugging in, so that you don't have to worry about the back-end design or the front-end design. There are many overlays that are available in the OpenLDAP. Access log is one of the overlays, so that you get to keep track of the activities that happen on the OpenLDAP, like the binding, the unbinding, the read, the write operations. Of course, you need not enable all of that. You could enable whatever is of your choice. Maybe it is only the write activity that you might want to log, so you can enable that. Audit log is another example. Maybe I want to generate an LD file which will contain the details about who modified what in the directory server. The password policy is yet another example of an overlay, wherein you have a set of rules that decides what kind of passwords can be used in an OpenLDAP server. So these are the different types of overlays that exist. Now let me just get back to the system I have here, so that I can show you the demo of the overlay there. It's a fairly easy procedure to have an overlay. By the way, for every single overlay that exists in the OpenLDAP, there is a corresponding man page. I talked about the access log overlay. If you want to get to know about that, you could just say slapO. That's the keyword, and then followed by that is the name of the overlay. So you can see that the slapO access log is actually overlay to the slapd. It's going to sit right in the middle of the front end and the back end, and what does it do? It actually generates the access logs. Access logs are normally logged into a separate database. In the subsequent segments of this section, we would be talking about how you could configure the access log, but this is one of the examples of an overlay. Another overlay that we would be looking at is let's say audit log. because we would want to have the audit information stored in here. So you can see that there is another overlay that's available in the form of audit log, where I could keep track of my modifications, the LDAP modifications, who modified it, into a file by using the audit log overlay. So I'm going to plug this right in the middle of the front end and the back end so that I could do something. Overlay does something. So let's do that. You would remember also that the crucial configuration file in the OpenLDAP, we modified that file when we created the database. The database that we created was dc is equal to fetg, dc is equal to com. In case if you are not able to recollect these discussions, I strongly recommend you go back to the section number 2, where we install and configure the OpenLDAP, and that's when we modify the configuration file, a very crucial file. So I'm going to edit that file. I would say etc, or maybe I navigate to that directory etc OpenLDAP, because I would like to take a backup of my configuration file, so that in case if I mess up, I can always revert back to the original file. So I'm taking a backup of the slapd.conf, a very important step in case if you are modifying any of the crucial configuration file of any software for that matter. Let me edit the slapd.conf file. And what am I planning to do? I am just planning to plug in an overlay. So let's go back to the database. There is a database that I've defined here. I'm going to create an overlay for this database, which is dc is equal to fetg, dc is equal to com. So all I'm doing is I would specify the overlay that I want is audit log. So what I've done is I specified the keyword overlay, and then I specified what kind of overlay I want. There are some predefined overlays that you could use. And like I showed you earlier, if you want to get more details about the overlay, there is a slapO-overlay name. The pattern, you would remember I used man slapO-access log to get to know about the access log overlay. I used slapO-audit log to get to know about the audit log overlay. And I also used maybe in the subsequent sections we would talk about the password policy overlay also, because we need to have a password policy in place so that the users who would eventually set passwords in OpenLDAP adhere to certain standards that you want in your site. So that's the name of the overlay, and I'm putting that right in the configuration file for the database. dc is equal to fetg, dc is equal to com. And then I would also say, okay, I want this audit log to be created under var let's say tmp slash fetg audit.ldif, because it's going to be in the ldif format. You would remember the ldif format. So what am I doing here? I'm specifying the location of the audit log file. So in this example, I'm trying to highlight how do you plug in an overlay in the configuration file, the slapd.conf file, and that's what exactly you see there. You say overlay, and then you specify what kind of overlay you are defining. In this example, I'm defining an overlay audit log, and then I'm simply pointing to the location of that file. By the way, I have actually another terminal of the same box. Let me just find out if there is a file by the name var tmp fetg audit.ldif. Now such a file does not exist, so it's very clear that the name of the file that I mentioned in the slapd.conf file does not exist here by default, obviously, because I just mentioned the name of the file in the slapd.conf. Nothing has taken effect so far. Now let's go back to the terminal where I modified the slapd.conf file. What you're expected to do after you make any kind of changes to the slapd.conf is to restart the server. Now restarting the server, the OpenLDAP server, is going to be slightly different in different operating platforms. I'm sure it is not a difficult task to go figure out how you could actually stop and start your OpenLDAP server, but you would remember in Solaris 11 we used svc adm restart ldap/server. Now that's going to be /etc init.d, some name stop and start in a different machine, like a Unix machine or a BSD flavor of Unix, or it could be service LDAP, service stop LDAP and start LDAP. So different operating platforms have different commands which does this for you. Let me restart my LDAP server. Now why did I do this? Because I modified the slapd.conf file. I would also need to find out if my service has come up fine, because if there is any kind of problem in my slapd.conf file, the service goes into a maintenance state. You might recall from the discussions in the section 2 that when I tried to start the service for the first time, it went into a maintenance mode because of the because of some mismatch in the slapd.conf file that I'd made. So I did a couple of things now. Edited the slapd.conf file, added an overlay by the name audit log, specified the name of the audit log file. Let's go back to the terminal and find out if that file exists. Again, the file does not exist. Now why is that? Because there has not been any event on my OpenLDAP server which could be audited. So I'm going to try some event here. I would say LDAP modify -d cn is equal to manager, comma dc is equal to fetg, comma dc is equal to com -w secret, and then let me first search for something because I'm not able to recollect what are the users who exist on my machine here. So LDAP search, and then specify the password, then specify where do I want to start the search. This is what we refer to as a base DN, and then I'm saying I want to get the entire entries. DC is equal to fetg, comma DC is equal to com. So is there anything wrong with that? There is no comma after this, of course. So I have a number of users in here. Maybe I'm going to play around with Sam Carter. Let's change the telephone number of Sam Carter. These are the entries that we played around in the previous sections. So Sam Carter is in finance. Let's clear the screen and then specify LDAP modify -d cn is equal to manager, dc is equal to fetg, comma dc is equal to com -w secret, and then I specify I want to modify Sam Carter, who is in the OU finance branch of dc is equal to fetg, comma dc is equal to com. Now what do you want? I want to modify. What kind of modification are you planning? I want to replace. And what are you replacing? Telephone number. Telephone number is what? Let's say 91900805742. Enter. Okay, now yeah, spelling mistake there. That's quite annoying because I will have to type the whole stuff all over again. And this is only in the interest of making sure that you get to see this many number of times, because I could use an LD file, which is the easiest way of managing this, but then the more I run this command by hand, the better chances for you to wire it onto your brain. So modify and replace telephone number. Telephone number is, let's say, 91900805742, and that's modified. Let's now go back to the terminal and find out if this file exists. Now yes, we go. There is a file that exists now. Let's find out from by using the tail command. Just in case if you're not familiar, tail -f would open this file dynamically for me. I would get to see all changes that happen in this file, fetg audit.ldif. Yes, there you can see that there was a modification that happened. A replace operation happened on that entry. That entry CSN number is also mentioned in there. And then you can also see who modified it. The modifier's name is cn is equal to manager, comma dc is equal to fetg, comma dc is equal to com. So if I try to do the same thing one more time, for example, it's going to populate the file again. So I think that's clear, that's evident. So I've opened the file in tail -f mode, so it's going to give me that information. I would say LDAP modify -d cn is equal to manager, comma dc is equal to fetg, comma dc is equal to com -w secret. Maybe I'll modify the same user again. cn is equal to Sam Carter. OU is equal to finance, dc is equal to fetg, comma dc is equal to com. Again, what do I want? I want to modify. Let's say modify. This time let's say delete telephone number, or maybe we will replace it. Replace telephone number, and we will give it a different value, 9194481114124. Enter, and you would be able to see that entry popping up in the audit log soon. So let's, oh, there was something missing. Let's run that again. cn is equal to Sam Carter. OU is equal to finance, DC is equal to FedG, comma, DC is equal to com. Change type, spelling mistake there, replace is equal to telephone number, and telephone number is 91944811424. Now let's go back to this file. You can see that there is one more modification that took place, and that was recorded in the audit log. So in this small demonstration, what we identified was about the overlay. There are different types of overlay which fits right in the middle of the front end and the back end of the SLAPD. There are many overlays that exist. Access log is one of the overlays, audit log is another overlay, password policy is another overlay. There are a number of them. You could refer to the OpenLDAP documentation to find out what are the different overlays that might be useful for you. We used one of those overlays, which is the audit log overlays. We put that in the slapd.conf. Now something really bad happened after we put that entry in the slapd.conf. I'm sure you noticed we had to restart the LDAP server, which was okay for me because I am running a test machine. But on a production machine with a massive number of users in OpenLDAP, a restart of the OpenLDAP server may not be a very desired situation. High availability, like I said, is anyone's concern. So we don't want our OpenLDAP server to be down for any moment of time, as far as possible, of course. So how do we plug in these information? How do we plug in these overlays dynamically without actually restarting the LDAP server? And that's going to be the discussion in the next segment of this section that talks about OLC. So I'll see you for a discussion of the OLC. As far as you've understood this, we are good.